Hello everyone, my name is Rupa Bayar. I lead the Versa Analytics Solutions. Today's topic is on observability for SASE. The agenda is as follows. We look at what is observability, see how it's applicable to SASE with some important use cases, look at Versa's observability solution, a quick demo followed by Q&A. What is observability? So by definition, it means the ability to understand what is happening inside the system based on what it exposes. The more observable a system is, more easily and accurately it can tell the root cause of a problem. Observability does not mean the same as monitoring, or it does not replace monitoring. It enriches monitoring. What monitoring does is it collects raw data and events from discrete parts of the system, and these are collected independent of each other. Monitoring can help you tell when something goes wrong. What observability does is it uses the monitoring data and can help you tell why something is wrong and how to fix it. Now let's take some real life examples. Consider your car. From time to time, you need to measure the tire pressure, and for that, you use a gadget called tire pressure gauge, which gives you some metrics in the unit of PSI. And unless you know what is a valid range for your car's tire, you would not know what action to take. Now, instead, if you were to be told that which of your tire pressure is low and what action to take. So in this example, it says that your front left tire pressure is low and you need to fill air. So the same metric became actionable. Now let's take another example. In this case, there is a blood pressure machine which typically will tell you your raw values, your systolic, diastolic pressure values, your pulse rate, etc. It does not have context. It does not take into account the user's age, health conditions, or any other information. But if you were to contextualize these raw values with the user's height, weight, activity level, health conditions, it can provide you much more actionable information. It can remind you of your movements. It can tell you if your heart rate is very high, and it can tell you if there is some unusual event happening in your body. So it can even save your lives. So by contextualizing the information, we are proactively and quickly able to tell you the root cause of a problem. What observability does is it actually enriches your visibility by adding more context to it. It provides you better alerts. You are not now needing to deal with all low-level information. You can subscribe to much more actionable alerts. Now you deal with lesser amount of data, so there's improved user experience. You spend less time troubleshooting issues, and also because of all this, you can have a better business strategy. Now, to implement observability, there are some key requirements. One is you should be able to stream various logs and events in real time. As much as possible, we should avoid sampling, because more data available, more easily we'll be able to figure out what actually happens in the system. Now, all these events and logs we should be able to send in a secure, reliable way to an external collector, because typically this observability solution will be in the cloud. So secure transfer of the logs are important. And standard-based telemetry is recommended because we should be able to easily integrate with any systems. Once the data is exported, we need an infrastructure to keep all these data, maintain all the mappings, the relationships between the various data. For this, we need a horizontal, scalable, high-performance platform. So a big data-based data lake is preferred. So this data lake should be able to provide a single pane of view for all the data that is stored. So once the data is stored in the data lake, we need to be able to contextualize and correlate all these raw data to get actionable insights. For that, observability tools may be needed to run over this data to generate those insights. And we also need to be able to get to the actual logs and events on drill down. So as you saw, like observability is not actually predicting anything. It's actually using the already collected data to figure out what may have happened. Now, let's look at observability for SASE. In the challenges with our current SASE deployments are that there are multi-vendor solutions. There's SD-WAN from one vendor, secure access from another vendor, SSE from the third vendor. Now, when we have this multi-vendor environments, there's lack of end-to-end visibility because all these different vendors logs using different formats. There's no consistent data model. And also there's multiple panes of views because each vendor might have its own portal. It might its own analytics a platform. So there's replication of infrastructure, which leads to higher cost of ownership. With Versa solution, what we have is all these different components, like there's SD-WAN, SASE, SSE, is from one software platform. So that because of which we have a unified infrastructure. You can apply policy uniformly across all these different entities. And also the data or the logs and events that are generated from these different entities have consistent data models, and it's stored in a single data lake, which helps you provide a single pane of view, not only for management, but also for visibility. Now let's look at some important observability use cases. The first use case is troubleshooting site reachability issues. In a typical SD-WAN environment, there might be thousands of sites, and at any point of time, hundreds of them might be down. So a monitoring and an analytic solution might tell you which sites are down, the number of sites that are down, and which of those sites are down. But why it is down is not known. So to troubleshoot such a issue is a very time-consuming process, because it will involve a operator to check various reports. Some of them are listed here. So one is like if a branch received a disconnect notification, if the branch was down for a long period of time, like was it a local issue, like because of device restarting, software crash, power failures, etc., or was it because of network issues such as underlays, congestions? Was there any WAN link failure or packet loss during the downtime? Or was there a config push just before the device reboot, and because of misconfiguration, the device rebooted? Or was there any other anomalies detected, such as packet buffer depletion, high service load, etc.? So a typical operator would go to different charts and try to analyze and figure out if what could be the root cause of this site going down. So doing all these steps manually would be very cumbersome. So what would be more beneficial would be to know the most probable root cause at the dashboard level. This would help reduce the time spent in troubleshooting the issues. However, it requires you to connect and correlate all these different information. And if we do so, what we will get is a high-level information such as this. We would get high-level metrics, which tells you what the breakdown of why the sites were down. So in this example, it says out of the 222 devices, 150 of them had network issues, 20 of them was because of some config change, 20 of them was because of some software restart. And sometimes you may not know why. After correlating also, there might be reasons of, we may not know why a certain site was down. So in which case it categorizes it as unknown. Now on drill down, we can get to see per site what is the root cause. Like in this example, branch 1 was down because there was a network issue, and it asked the user to go and contact the underlay provider. Branch 2 was because of power failure, and it asks you to check the power supplies, cables, etc. So it gives you very low level, very detailed information and what action to take per issue. Now let's take the next use case of user experience. In a typical SASE environment, the users may be connecting from behind a branch or from behind or from his home or from anywhere. He might be accessing his applications, which might be behind the DC or on the public or the private cloud. So the user's traffic may span multiple devices as it spans from as it goes from the source to the destination. So these traffic sessions may get dropped at any point due to various reasons. Some reasons could be policy violation, due to congestion or lossy network, due to threats, vulnerabilities, or due to device failures. Now, so it is important to be able to troubleshoot end-to-end where the users, and troubleshooting of this end-to-end traffic activity is important to know where the user's traffic got dropped. Now, let's take an example of a user, Jane at versanetworks.com. She complains that she's not able to download a file and she's getting this error in her browser when she tried to do this activity from her home around 6 p.m. on Jan 31st. Now, when she tells this to her administrator, the administrator will go to your analytics platform and will look for the user's destination IP of the user or the user's source IP or application and look at all the raw logs. And when there are so many of these logs, and unless you are a network or a security expert, you may not know what exactly happened for the user's traffic. Instead, if we connect and contextualize all this information, you can get a high-level information as shown here. User Jane at versanetworks.com tried to download a file using remote client from San Jose, California, and the traffic session was dropped due to virus detected by the San Jose gateway. So now she knows exactly what happened to her traffic. Now, on further drill down, she can see the detailed view of how the traffic was handled by the SASE network. So the user connected from her home in San Jose to San Jose gateway, and the traffic from there was natted and sent over the SD-WAN overlay to a Bangalore data center because the server was sitting behind the Bangalore data center, and the file was downloaded from the data center, but on return path, the file got blocked because there was some potential virus event detected. Now, it is very easy to figure out what happened, but on further analysis of the event, the user figures out that it is not a real virus, it's a false positive, and she can contact the administrator to allow downloading the file, or if it is in fact malicious, the administrator can delete the file from the target server. So by connecting all this information, we can easily know what action to take and why something happened and what action to be taken. Now let's take the next example of application experience. So for application experience monitoring, typically we use various passive and active monitoring techniques to derive various information such as loss, round trip time, retransmissions. So what passive monitoring does is it intercepts the customer's traffic. It analyzes the TCP metrics. And in case of active monitoring, we periodically monitor the destination server using wget, ping, etc. And all these metrics can be used to derive a performance rank. This performance rank can help you know whether the application experience was good, bad, or degraded. However, why it was bad or degraded requires further analysis. So now let's consider again the SASE network where the user may be coming from behind the branch or from his home or from anywhere. So he might be accessing some SaaS application or some public applications. So the problem could be anywhere here. The problem could be at his client network due to network issues from the client to the gateway, or it could be his device due to high CPU, memory, disk, queue, etc. It could be on the SD-WAN overlay if the traffic is sent like due to some underlay issues of packet loss, latency, congestion, etc. It could be on the branch or the hub devices because of low resources, overload on these systems, or various anomalies, or it could be on the application server due to high application response time. Maybe the application is overloaded. Maybe it is accessing some database server which might be very slow. It could be due to also network issues from the gateway to the application server. Now, in a typical environment, we would provide like application performance rank per application, which tells you whether the application experience was good, bad, or degraded. But if you want to know what was the reason for the bad experience, you need to further analyze various raw metrics. So the first metric here is based on passive monitoring, where per application, per user, we collect metrics such as the network response time, application response time, server response time, retransmissions, etc. If it is going over the SD-WAN network, it will provide you site-to-site metric. You will need to check the site-to-site metrics such as delay, jitter, loss, etc. Or the last leg, that is from the gateway to the application server, can be monitored through this application active monitoring, where you can get to see the loss, latency, jitter, etc. Now, all these metrics can be correlated or connected, and we can get a high level root cause of the various issues. So in this example, per application, per user, the root cause is categorized as is either a client issue, as SD-WAN issue, branch issue, or the application server issue. And on the further drill down, which it can provide you details of what was the reason for the failure, like client to gateway one was failing, or whether which of the underlay part was having poor performance, whether the branch saw high cost drops, etc. So by categorizing into these high-level categories, we are easily able to triage the issue, and then the network operator can then delegate the issue to appropriate teams. Now let's look at Versa's observability solution. So for implementing observability, Versa has a managed cloud-hosted advanced logging service. What it provides is it's a unified data lake which can scale on demand, which can provide a single pane of view and reduce complexity for operators by maintaining all of this data in a unified environment. What Versa will be providing is a new observability service which uses this data that is stored in all this local as well as your advanced logging service cluster to get actionable insights. Now, if you now look back at all the key requirements for supporting observability, Versa has most of it. We do already real-time streaming of various logs and events. We have very granular data that can be streamed. We have advanced login service which acts as a unified data lake, which can provide you a single pane of view, improved user and administrator experience, reduce TCO. And we have an analytics platform which can be used to connect and contextualize the data. What we need to do further is to write these tools to get those actionable insights. Now we have an advantage here because now all this data are generated from our own devices. So while generating the data itself, we are able to connect most of the time the data so that the resources required to obtain some of this observability information can be optimized. So for example, in the case of user experience monitoring, we are able to tie the logs between various devices using some correlation ID, so that even if it gets natted, or even if the even if it crosses network boundaries, it's able to figure out what the related flows. Now let's look at Versa's advanced logging service in detail. So what you see on your left is your on-prem environment, which is having your analytics and search instances as well as the log forwarder instances for processing all the default logging. So the logs from your branch devices are by default sent to your on-prem cluster. Any high volume logs which require which requires larger infrastructure can be sent on a secure channel from the branch through the controller to the advanced logging service solution. Now, from the visibility point of view, you will still access your Director Analytics portal, and anything stored in your local cluster will be retrieved from there, and anything stored in the advanced login service will be automatically retrieved by the application from the ALS cluster. So as you can see, all the data is available in your portal without having to go to multiple portals. So it provides you a single pane of view, and it provides you a scaled environment which can which you can subscribe to on demand. Since it's Versa managed, all the complexity of maintaining and monitoring this data is avoided, and all the information can be retrieved, be it monitoring or observability, from your single portal. So finally, to summarize why observability matters in case of SASE is that there are these environments are highly distributed. So ability to enrich various data retrieved from these different endpoints helps greatly to generate actionable insights, which helps in reducing the mean time to detect and recover any failures. And also it provides better business outcomes by improving your productivity and reducing cost. Now let's look at a demo of advanced logging service. So this is our analytics portal of 22.1. So if we need to, so this acts like your on-prem cluster. So if you need to enable advanced login service, all you need to do is set up connectors in your portal. So in this example, we have connected to the European Advanced Login Service cluster. And when you subscribe to this service, Versa Managed Service Team will provide you the credentials to log in to the advanced login service. And so we save those information here. And once the connector is configured, you can associate that connector configuration to any of the logs that for which you want to send it to advanced login service. So in this example, for this Corp Inline Customer 1 tenant, I have enabled all the security logs to go to advanced logging service cluster. So what here we are doing is, from the application point of view, we are saying that all these logs, if you need it, you need to use this connector to retrieve the data. Additionally, on the branch devices, what you will need to do is create different logging profiles, another logging profiles for streaming the logs to advanced logging service. So that logging profile will be pointing to the destination, which is provided by our managed service cluster, managed service team. So once you save the configuration, as you can see, all the threat-related information is associated with the advanced login service connector. So once we save, you go to the logs hierarchy and go to any of the threat features or firewall kind of features. It will automatically retrieve the data from the advanced login service cluster. So as you can see, in a day, there are more than 45 million logs for this tenant, and it was quickly able to retrieve that. And then we can quickly search on various logs and events to get actionable insights. Now let's come to some questions. I have a few questions posted. So is observability going to be available in Concerto only or also in analytics? So when we support observability, this data can be retrieved through APIs, and it will be available both in Concerto as well as in analytics. So the next question is, when will the feature be available? So this feature is planned for second half of this year, maybe Q3 or Q4. So as you saw, most of the requirements are already there. So what we're working on is trying to connect and contextualize the data as much as possible when we ship the data from the devices, so that when we have to generate this, when we have to write the tools to retrieve this data, it will require less resources. So what is missing is the tools for generating actionable insights and also some visualization related to it. The next question is ALS a must for supporting observability? So some of the use cases which are very simple, like maybe site reachability issues, we may be able to retrieve the data. Um, we may be able to generate this observability based insights using your on-prem solution itself. But most of the time, it needs flow log related data, and which requires detailed logs to be generated from the devices. And for this, we recommend using ALS. So without ALS, there will not be a solution. I think that's all I had. Thank you, everyone. Bye.